Morning. Hello. Oh, really? Yeah, that's probably gonna need that. I mean, there's no fun. I mean, there's fairly. Like that. Thank you. But you want. What's that? Yeah. Do video. We always do. Every once in a while. Actually, I think the second time. I want to do it more often to say other people are happy from here. Good morning. Friday. Today we began applications. Exponential stuff we've been doing. So about formulas, don't worry about it. You know, about 10% after a year. After a year. We ready? Why it's coming? It's on this way. Woo. Kate, I don't see Kate yet. Okay, Layla, can you help us out with this? So after 1 year, do you have any idea how much money this person would have? Okay, so 10% of 2,000 is what? Is 200. Okay, so after 1 year, how much money do they have? They have the original 2,000. 2,200. Are we good with that? Now, if this were simple interest, they would just get $200 every year. That's the kind you might learn about in 5th grade. The world doesn't work that way. The world works by not simple, but compound interest means the bank recognizes that they have more money in the bank. So that's like they're depositing 2,200 in their first year. They're gonna have more in the second year. So Leila, how much are they gonna have after? Like, how much money are they gonna make this next year? Like they made 200 the first year. How much are they gonna make the second year? Well, good. You did 10% of 2,000. Now the question is what's 10% of it? Yeah, 10% of 220. Oh, so 220, is that what the answer is? So right, so now we're doing 10% of 2,200 is 220, so they're gonna have 2,420. Did I do that right? Okay, finishing this off. Kate, what do you? I'm just kidding, Kate. I'm gonna give you a chance. Grace. Grace, can you help me out here with that third year? What's gonna happen here? No, I'm sorry, Grace. I should be more clear. Okay. Two, okay, so we get 2,000. Is that right? Any questions from this? Simple calculations like that 220, rather than take 10% and then add it to the 2,000, we could just take 2,000 and do what with it to get that 2,200 immediately. Like times what is going to equal 2,200 basically is what I'm saying. Does it make sense? 1.1. One comes from the fact that we're keeping the 2,000, and then the 0.1 comes from the fact that we are adding 10%. And then the next year, we could take that 2,220 and multiply it by 1.1 again, which is the same thing as 2,000 times 1.1 squared, isn't it? Which would give us that 2,420, and then maybe we can kind of see the pattern here, 1.1 to the third power would give us that final one. It give us 2662. I want to make my calculations as simple as possible. So I know you've studied exponential growth and compound interest before, but hopefully just an exercise like this helps us put the pieces together as we go over. some personal finance stuff, compound interest. Okay, so compound interest again, which means making money on the money you've already made, which is a pretty good deal. So the basic formula is P times 1 plus, first it's just times R to the, we will get to the NT, you're correct, we are getting there, but this is just if it's compounded once per year. Time is usually in years. R is always written as, it's a rate written as a decimal. So hopefully you can see how this relates to what we just did. P stands for the principal, which is just the starting amount. So this is the basic one, but banks also realize that you don't just keep your money in for a year and then at the end you get that 10%, you get that 10%. So it could be compounded in the middle of the year, right? So it could be compounded semi-annually. So you don't get the 10, if it's 10% yearly rate compounded semi-annually, that means after 6 months you would get 5%, and the second, at the end of the year, you'll get another 5%, which would actually give you a little bit more money because you're making money on money that's already there. So the other formula we have is, and this is, I think, Maya, what you're referring to, right? We take that rate divided by n, and now we raise it to the nt. So n is the number of times compounded per year. T is the number of years, P is the principal, A is the resulting amount of money that is left. So I'll give you a minute to go over these two, and I'll call on a couple people to help us out. So we tell us what we did for A, B. We agree? Are we good with this? Now, I hope it makes sense. Once it makes sense, it's not about memorizing, it's just putting the pieces where they naturally fall. So here, it's the same thing, except the twos are gonna be replaced with fours, and we get that the amount is equal to, let's do this together. I know it's gonna start with a 22. I think it's gonna have the zero. Is the next number 8? Can you do this? Is the next, did you already calculate this? Is the next number 8? It's not. Oh, it's not 0. It's 1. Oh, 6, 7, 4, 5. Is that right? 1, 5. All right, we are complete. Glad you made it. Any questions about getting there? Are we okay? Okay. Continuous compound. Okay, so this means banks are realizing that you have money there, not just twice a year, not every 3 months or monthly or daily. They're taking into account that you have money there in the bank all the time. So they're taking that 6% or 4% and cutting it into how many pieces? Well, if it's continuous, they're cutting it into an infinite number of little pieces that all add together to be whatever the rate is. So let's develop this. We're gonna start with this p times 1 plus r over n to the t. We can't, oh, not to the t, it's to the nt. Now we can't just make n infinity. You can't just do things like that. What I'm gonna do is I'm gonna manipulate this algebraically a little bit. I'm gonna see where we go. So I'm gonna have you put your pencils down. Just watch and enjoy. I'm gonna just play with this a little bit. Do we agree that this is the same as this, that these two are equivalent? Actually, I'm gonna play with this. Let's see, n over r times rt is this equivalent to what I started with? I think it's weird, but I'm gonna simplify this by making a substitution. And again, just watch. Let h equal n over r. So I could rewrite this now as area equals p times 1 plus 1 over h to the h RT. Yes. And since, remember, my goal is to have n go to infinity, right? N is at infinite of time. So if n is going to infinity in this fraction, what makes sense that h is also going to infinity? So we're taking this expression here, and we're having h go to infinity. In other words, we're taking the limit as h goes to infinity of 1 plus 1 over h to the h. What is that? Do we know? Let's look back. Do you have anything like that? Let's see. Did I skip over it? We talked about this? And this is the one you know. What's the word that you might associate with it? Hurt. And yeah, that was a good time to write this down. This is just equal to amount is equal to P times E to the RT, like that. A beautiful formula. R represents the yearly rate. T represents the same thing, how many years. Now, it's usually years, right? But what if like the rate is a monthly rate or a weekly rate, then it'll be weeks. But we're talking about money in the bank or something like that, or a loan. It's usually a yearly rate, so it depends what the T is. So find the amount that results from $10,000 invested at 4% compounded continuously after a period of 20 years. Go for it. Do you have the same thing your neighbor did? Kate, did you get an answer for this? Yeah. For example, two? Yeah. Okay, what'd you get? Oh, two, two, two. Does, does this match what you all got? Cool, thank you. Dollars. So what do we notice about all three of the previous investments? They're similar and yeah. Do they get closer to each other? I think that's where the more compounding equals more money. So I guess what you're saying is it's approaching that upper number. Yeah, it's definitely approaching that upper number. And I don't think we could compound it anymore. That is the maximum we can get compounded continuously. And that is what banks do, which is to your benefit. It's not a huge benefit unless you're working with tons of money. But it is a benefit. Any question about this? Okay, I hope it makes sense. Let's see what you can do with exercise. Oh, example 3. Make sure your neighbor is started. Someone help me out. What's the key to making this work? Yeah, Ava, are we good with that? 5p, or is it just anything 5p? Good. Keep on going from there. We'll be asking for help from someone to solve it. Are we done? You'll probably need a calculator. I'll call on someone in about 10 seconds. It should have a direction to go from here. Okay, Sienna, can you help us out? Oh, could you help me solve this one? What's that? I know it's both, right? So compounded semi-annually. Did you do semi-annually? Okay. And then we'll do the continuously. What do I do next year? Okay. Ooh, nice. Okay. Thanks. 2 times log of 1. Are we good with this, everyone? Do you want to do the crunch out in your calculator already? Did anyone, yeah, is that what you get? 27.2 years. Thank you. Do you want to continue with the rest of this? Or? Yeah, with the continuous one. Yeah. Okay. Okay, 6.8 years. Thank you, Sienna. That's great. Yes, Addison? There, yeah, where is that? Math. Math and scroll down. Oh, alpha window does it too? Oh, interesting. Oh, that gives you all the same options, or it doesn't go right to log base. Okay. Don't abuse that though. Make sure you don't forget how to go to common log and exponential. Yeah, and for this one, also don't forget that if you just rewrite this in logarithmic form, you'll have the same thing. So either take the ln of both sides, log of both sides, whatever you need to do. Okay, example 4. We're good? Easy? Do we need to go over it? Did you get the money? Does he have enough? For the monthly he does, but for the compounded continuously he doesn't? Okay, yay. I was thinking, that's a really long time to wait for $60. So I was thinking, why don't you just get a part-time job or something like that? And I was thinking, in my day, kids would just babysit. Does anyone have babysit? You have babysat? Okay. Um, I don't know. What would a teenager do for a part-time job these days? Okay. Oh, nice. Okay. Is that like weekly you do that? Okay. Where? Okay, very cool. What else would the high school students do for part-time work these days? That's it. That's the only job available. Yeah. See you later. Oh, and is that like just walking or you like hang out with the dogs or? That seemed like a great opportunity. Plus you get to hang out with dogs. It's only win. And I imagine for both of those, you would make more than $60 in much less than a year. Anyway, moving on. Effective rate of interest. Effective rate means like the fact that you're making more money means that that percent is bumped up above whatever is quoted, which is kind of interesting. Like in the problem that we started with, the warm-up problem. If you look at it, you're actually making more than 10% compared to what you start what you start with and what you end with. So let's talk about what happened to this. Let's just like put it all the way down there. Okay. So what rate of interest compounded quarterly will yield an effective interest rate of 7%? Okay, compounded quarterly. So I'm going to use my amount equals principal times 1 plus not R, but 0.07. Oh no, I'm sorry. It's asking the rate, so I need to put an R over here, divided by 4 to the 4 times 1. And then the question is just what's going to leave me with a final amount of 1.07 of that which we began. So again, the question is what's going to leave me with flat 7% compounded quarterly? So to solve this, I'll give you a moment. Well, I'll help you. Cancel the P's. Okay, can you solve it? We'll be calling on someone. navigate through this one? Perfect. Okay. Okay. Good question. Can we distribute logs? It's tempting, isn't it? So tempting. Yeah. Yeah, I think what's happened is you did a thing that you could do, but it didn't take you in a direction that's helpful. So we have to find something else to do to get to isolate that four. So instead of taking the log, I can kind of unpeel that four away. If Eva, you want to, would that make sense to take the fourth root of both sides? Okay, so 1.07 to the oh, that's the one. I'll make it the fourth root. The fourth root. And then this is equal to 1 plus r over 4. And I think that happened out here. So we get r equals the fourth root of 1.07 minus 1. Oh, times 1. I don't know how to put that up. Times 1. Did anyone get an answer for that? 6.8%. Any questions? Well, it makes sense that the rates that we would have is less because when it's compounded, you actually get more money. So how would I explain the rate of interest? It's, the actual increase in value after a single time period. It doesn't have to be a single time. It could be over 20 years, but it comes down to what's the annual interest rate. For B, okay. I will be calling on someone in just a moment. So Maya, can you help me out with this one, please? Like this. Oh, I guess T is 1. Oh, you're right. We already did the R. Yeah, just to the R. Thank you.
And then I get, I think that, after all of those guys, the other one, where I think that to be another, and after all, I think that there's like,
5.8%. Are we okay with this? Very nice. I think that's enough for us to do together. So I'm gonna give you some time to relax while I put your homework together. I'll tell you when it's ready.